In this video, we'll see how to use recursive partitioning to predict a numeric or continuous column as a function of potential predictor variables. For this example, I'm using the diamonds data available in the sample data directory. To start, we'll go to the Analyze menu, select Modeling, and select Partition. Next, we'll specify our response variable. In this case, it's price. Next, we'll specify our factors. In this case, the remaining variables. In Jump Pro, we have the additional option of specifying a validation column. We can also specify in Jump or Jump Pro a validation proportion. In this case, I'll put the portion to be 0.30. Jump Pro also offers two additional methods, including Bootstrap Forest and Boosted Tree. Here, I'll leave the default option selected, which is Decision Tree. When I click OK, Jump will produce the basic partition output. Before performing any splits, we're given information about the average response for Y, in this case, the mean 3962 for the price of diamonds. We can also see that 1,873 observations will be used for training and 817 will be used for validation. The numbers that you receive, if you are following along, may differ from this. To see the candidates for the first split, we can expand the candidate section under all rows. This shows us, among the different variables, the candidate sums of squares for the cut points that we have obtained. To perform a split, I'll click the Split button, and Jump will split these data at the first most explanatory cut point. In this case, carat weight being less than 92 versus carat weight being greater than or equal to 0.92. On the basis of the split, we can see that the mean price differs substantially for carat weight less than 0.92, which on average had a price of $22.30, and those diamonds with carat weights greater than or equal to 0.92, which had an average price of $6,039. To make an additional split, we can click Split again, and Jump will make the next most predictive split using our data. In this case, splitting up those diamonds that are less than 0.92 into categories less than 0.74 and greater than or equal to 0.74. Because we are using a validation column, we can also let Jump do these splits automatically by clicking Go. Jump will show us the split history, including the validation and training R-squares. Validation data is shown in red. Additional options are available under the topmost red triangle, including the very useful output of column contributions, which shows us, for each column, the total sums of squares that those splits have contributed. In this case, we can see that carat weight is our most explanatory variable, as it was involved in 53 of the splits and accounts for the largest portion of the sums of squares. In addition, from the topmost red triangle, we can also save columns, including the residuals, predicted, prediction formula, or, if we like, we can make a SAS data step. For more information on fitting and evaluating regression trees, including validation, Bootstrap Forest, and Boosted Trees, search for Partition trees in the Jump Help or in the Specialized Models book.